Hello everyone. My work aims to solve the video compressive sensing reconstruction problem for high frame rate cameras. High frame rate cameras needs high transmission bandwidth and large storage space. And for a 1084 resolution cameras, it will generate about 500 gigabytes data and a frame rate of 10 kfps. And the maximum achievable frame rate for a high frame rate camera is limited by the sensor's pixel readout rate. And the same sensor may achieve either a slow frame rate and full resolution or a fast frame rate and low resolution. And spatial resolution must be sacrificed for temporal resolution within a fixed bandwidth. Here, our work aims to overcome this fixed bandwidth constraint and achieve high frame rates without sacrificing the spatial resolution. This is an overview of compressive sensing. Compared to the traditional samples and compress method, compressive sensing can directly sense data in a compressed form. The limitation of prior reconstruction work lies in the slow reconstruction speed because they usually rely on the sparse constraint, and we need to solve a complex optimization-based method to get the solution. Also, the most motion estimation problem is computationally expensive, so the prior work suffer from slow reconstruction speed. Also, when the number of measurements is lower than the measurement bound, the recovery quality will drop quickly. Also, the prior work needs to solve a iterate-based process to get one reconstruction, so there's data dependency, which is not hardware friendly. This is our proposed video reconstruction approach. And here, to improve the spatial resolution, we use a random encoder encodes the keyframe in a group of pictures with more measurements and the remaining frames with less measurements. And a dedicated scene is used for feature extraction for each compressed frame in a group of picture. And we use recurrent neural network to extrapolate motion from the feature maps that is extracted by the CNN and use it to improve the temporal resolution of the final video. During the training, we first pre-train the multi-rate CNN, and we use the intermediate feature maps output and the input to the LSTM, and then we train the entire CNN LSTM model. This is a quantitative evaluation result on UCF101 dataset. The first table is a comparison result with the conventional image compressive sensing reconstruction method, and the second is compared with the video construction method. We can see the advantage of our method becomes more obvious when we improve the compression ratio, and our method suffer from least performance degradation compared to other methods. This is the video quality comparison, and we can see the proposed method provides the finest details among all approaches, and the edge provided by our method is much sharper, while such details are almost lost by other methods after the reconstruction. This is runtime performance. We compare the runtime comparison. We compare the runtime performance for reconstructing a 160 by 160 video frame and different compression ratios. And we can see the proposed method is much faster than the reference method, and the advantage becomes, and our method performs, and our method have much better recovery quality compared to our other method. Conclusion, our method provide a viable solution for high frame rate cameras. it is also energy efficient. Thank you.